let's start with another type of problem in this particular video. Now, this is also based on continuity itself. All right. Look at the question. Find the values of k so that the function f is continuous at the indicated point. Now, here I have just specified that you have a value k. You can have any variable. Understood? Now, why I'm saying you can have any variable? Because you can have lambda, mu, alpha, beta. You can have any variable, but you will have some unknown. Now, let's start with the first one. See, in this, the first one, look at it. F of x is k cos x divided by pi minus 2x when x is not equal to pi by 2, 3 when x is equal to pi by 2, at x is equal to pi by 2. In the sense, see, the function is continuous. Look at the question. F is continuous at indicated points. That means, in the first one, this f of x is continuous at x is equal to pi by 2. Make sense? Given that it is continuous, what should be the value of k? This is what we are looking at. All right. Now, to solve this one, what do we have? Remember, if it is continuous, LHL is equal to RHL, correct? So, what do we do now? We take LHL, RHL, both are equal, and that is equal to the limit at the particular point, isn't it? So, now limit as x tending to pi by 2 minus, or you can say pi by 2 plus also. I mean, because both are one and the same anyway. F of x is equal to limit as x tending to pi by 2 f of x. Don't take LHL or RHL, just the value of the limit. So now, what do we have? K cos x divided by pi minus 2x. This value is basically equal to 3. Guys, you cannot just do like, take it to RHS, multiply the cross multiply. You can't do it that way because the reason is we have a limit on the LHS, correct? So here what do we have? We have limit as x tending to pi by 2. Of course, you cannot just directly take it this value because you'll get 0 by 0 form, isn't it? So we need to do it in another format. Make sense? So now how do we solve this one? We need to solve limit k cos x by pi minus 2x. Correct? Now we need to solve the limit here. Fine. First, what do we do? You can solve this in multiple ways. All right. Take the cos as sine of pi by 2 minus x. Complementary angle. So the numerator becomes k into sine of pi by 2 minus x divided by, take 2 common in the denominator, 2 into pi by 2 minus x. Limit as x tending to pi by 2. Now, you might be thinking, why do we have to do it this way? Like, what is the point? Now, if you remember, last year in limits chapter, you had done one particular formula. You have derived and used it. Limit as theta tends to 0, sine theta by theta is equal to 1. So, if you cannot use cos, then convert the cos to sine. And since we have pi by 2 minus theta, or pi by 2 minus x in this case. So instead of theta, we have pi by 2 minus x. That's why we need to convert it in this particular form. Clear? So we are going to get this. So what do we have now? See, this entire value is going to become 1. Isn't it? So you get k by 2 is equal to 3. So k is equal to 6. So the answer what you have is k is equal to 6. This is the answer for the first question. Now let's do the second one. For the second one, f of x is equal to, see, kx plus 1, this is cos x. This is where x is less than or equal to pi, and here it is x is greater than pi. Alright. And you know it is continuous at x is equal to pi. Okay, well and good. First we'll take one limit, that is limit as x tending to pi minus LHL, no? f of x is equal to limit as x tending to pi plus f of x, correct? So LHS, or sorry, not LHS, LHL, sorry, LHL becomes kx plus 1 limit as x tending to pi minus, this is equal to cos x limit as x tending to pi plus, correct? Now what do we have? So you take a value k into pi plus 1 is equal to cos pi is what? Cos of pi is -1, isn't it? -1. So take it this way, you get k pi is equal to -2. So k is equal to minus 2 by pi. So this is going to be the value of k. This is how we solve this one. Alright, let's do the third question now. See the third one. F of x is equal to kx plus 1 when x is less than or equal to 5, 3x minus 5 when x is greater than 5. Same logic, isn't it? Now what are we going to do? First, limit as x tending to 5 minus f of x is equal to limit as x tending to 5 plus f of x. For the left hand limit, the function is kx plus 1. For the right hand limit, the function is 3x minus 5. Correct? So you are going to have limit as x tending to 5 minus kx plus 1, limit as x tending to 5 plus 3x minus 5. Correct? Apply the value of the limit because you know it is continuous at x is equal to 5. So since you know what we are going to do, if you substitute, you will get k into 5. So 5k plus 1 is equal to 3 into 5 minus 5. Correct? So 5k plus 1 is equal to 15 minus 5. 5k plus 1 is 10. 5k is equal to 9. So k is equal to 9 by 5. So we got the value of k as 9 by 5, which is going to give me the value of k. Very easy. Clear? Let's do the fourth one. See the fourth one, it's a little tricky because we have two variables, a as well as b. Correct? Now we need to get the value of both a and b. That's what I was telling. When I say find the value of k, it's not just k, it can be any variable, a, b, lambda. Here we have lambda for the fifth one. You can have any variable, or you can say some unknown value. Alright? See in this case, first thing what we are going to do, first take f of x. So we have 5 when x is less than or equal to 2. Ax plus b when x is between 2 and 10. And 21 when x is greater than or equal to 10. Now in this case, what we know is that it has to be continuous. Remember in the previous video, we used to do that it is continuous, discussion of the continuity in two different points we were taking. Likewise, here also, what we need to take, we have to consider 2 points. One is 2, one more is 10. Understood? We'll take 2 cases. So in the first case, we'll call it as case 1. This is the continuity with respect to 2. Alright, first condition. So here what do we do? Here we take LHL, that is limit as x tending to 2 minus f of x is equal to limit as x tending to 2 plus f of x. Correct? So when you talk about 2 minus, what do we have? Limit as x tending to 2 minus function is 5. That's all. The value of the function itself is 5. So this is equal to limit as extending to 2 plus ax plus b. Correct? So what do we have? 5 is equal to 2a plus b. We can't do anything for this one. So what we do? So we put it in a box and then we call this as equation number 1. Fine. So case 1 is done. Next, what do? We take case 2. Alright. For case 2 now what we are doing? Continuity with respect to 10. Correct? So in this, you have limit as extending to 10 minus f of x is equal to limit as extending to 10 plus f of x, isn't it? So the left hand limit now, limit as extending to 10 minus ax plus b, right? So why we take ax plus b? Because see, x is less than 10, correct? So this is equal to limit as extending to 10 plus, this is 21. I mean, it's not a function as such, but it is just 21, isn't it? So now what do we have? 10a plus b is equal to 21, correct? Now we'll call this as equation 2. Now we have two equations. We need to solve for these two equations. All right. The first equation was what? 2a plus b is equal to 5. The next one was 10a plus b is equal to 21. Isn't it? Normal linear equation solving. Now you subtract. See what we are doing here? We are subtracting these three equations. See, when you subtract, b gets cancelled. So minus 8a is equal to minus 16. So a value becomes 2. Correct? So what do we get? One of the values. A value is 2. Substitute. So you have 2a plus b is equal to 5. 4 plus b is equal to 5. B is equal to 1. So b value becomes 1. So what are the values now finally? So here a value is 2 and b value is 1. Clear? This is how we need to solve the fourth one. Now let's do the last one, the fifth one. See the fifth one? Again, you have f of x is lambda into x square minus 2x, where x is less than or equal to 0. 4x plus 1 when x is greater than 0. You know it is continuous at x is equal to 0. Correct? So now what do? Limit as extending to 0 minus f of x is limit as extending to 0 plus f of x, right? Now what do we have? Limit as extending to 0 minus lambda into x square minus 2x. Limit as extending to 0 plus 4x plus 1. This is my right hand limit function, isn't it? Now what do? See, if you apply the value of x as 0 in both the cases, okay, if you take it as 0, then see your LHL, you will get 0 minus 0, which is 0 itself. So lambda into 0 is equal to 1. So lambda into 0 is 0. So can we say that 1 is equal to 0? Not true, isn't it? So directly we won't be able to solve this particular formula or this particular question, you can say. Okay, now we need to look into this one in some other way. Understood? Let's look at it that way. So first what we'll do is, rather than directly applying, let's try to take a particular value outside. Maybe x is common, we can take x outside. Let's try to solve it that way. Now what we can do? Limit as x tending to 0 minus lambda x into x minus 2, limit as x tending to 0 plus 4x plus 1. right? Now, if you apply x value as 0, doesn't matter when you're going to apply. So what will you get? Lambda into 0 is equal to 4 into 0 plus 1. 0 is equal to 1. Now, is this possible? It is never possible, correct? Now, since 0 is not equal to 1, so what can we say? For any value of lambda, that means for all lambda belonging to R, LHL is not equal to RHL, correct? You take whatever value of lambda, doesn't matter. LHL is never equal to RHL, correct? So for all lambda belonging to R, since LHL is not equal to RHL, you can say lambda can take any real value. Understood? So you can say since LHL is not equal to RHL, here what we can say, lambda can take any real number. Any real number. Because anyway it doesn't matter. You can have lambda to be 100 or 100,000 or 0 also. Makes no difference. So what we can do for the last one is, for all lambda belonging to set of real numbers, LHL is not equal to RHL. So lambda can be any real number. Understood? So this is the answer for the fifth one. So these are different types of problems. If you look at the last video and this video, we have discussed different types of problems. First is you proved whether it is continuous or not. Second one, you discussed the continuity. Like at this point, is it continuous? At this point, is it continuous? For this range of values, is it continuous? Correct? Then for what all values, this particular, whatever we have, the value of k, a, lambda, whatever it is, for what value is it going to be continuous or not? Correct? So these are all different types of problems what you have in continuity.